For our lesson number 7, we have the equilibrium of non-concurrent or parallel force systems. A body is in the state of equilibrium if it is at rest or moving at constant velocity. As there is no translational or rotational acceleration, the condition of equilibrium for general three-dimensional system can be expressed as summation of moment to A is equals to 0 or summation of Fy is equals to 0. Here's a given problem that says determine the value of all the reactions. The figure below is a beam with a hinge and a roller. We have here different types of load, which is the trapezoid with 10 kilonewton load and 5 kN, and a rectangle with a point load of 20 kN and with an area of 5 kN per n, and a point load of 5 kN, 3 kN, and 10 kN. We also have a triangle below with an area of 6 kN per m. And here are the distances of the beam, which is 3m, 2m, 3m, 1m, 1m, and 1m. So to solve for our beam, we must first get all the reactions and assume that the hinge is RA and the roller is RB. So the next step is we're gonna moment all the load. Since we're going to moment at A, so we have to get first the area of the load, which is the trapezoid. So we will divide it into 2. So this will become triangle and rectangle. So since it is a trapezoid and we're going to moment at A, let's assume that the centroid of triangle is 1/3 since it is in the higher part. The higher part is always 1/3 and the lower part is 2/3. Then the formula of area of triangle is 1/2 times base times height. And the rectangle is base times height. So to get our RB or to solve for our RB, we have to get the area of triangle first since it is 1/2 base times height and we divide this into 2. So 1/2 times base 3 times height 5. So 5 times 3 times centroid of triangle. Since the higher part is always 1/3 and the lower part is always 2/3, so 1/3 times 3, centroid of 3, plus our area of rectangle, base times height is 3 base, and height is 5, plus centroid of rectangle, 1/2 times 3, minus RB, since counterclockwise to A, and the distance are 5, since 3 plus 2 is 5, so minus RB times 5 plus point load 20 kN, moment to A, clockwise, so it's positive, and the distance are the same, so it is also 5. So 20 plus 20 times 5 plus area of rectangle base times height is 3 times 5 plus 3 times 5 times centroid of 3, 1/2 times 3, and our point load 5 plus 5 plus our point load 5 kN, moment to A clockwise, so 5 times 9, since 1 plus 3 plus 2 plus 3 is 9, plus our point load 3 kN clockwise, so positive, plus distance 1 plus 1 plus 3 plus 2 and plus 3 is 10, so plus 3 times 10. Our point load 10 kN clockwise, so positive, plus 10 times distance is 11. So 10 plus 11 minus our triangle, moment to RA, counter, so minus 1/2 times base, our base is 3, times height 6, so negative, since, so 1/2 minus 1/2 times 6 times 3, centroid of triangle, this is 2/3, this is 1/3, so 2/3 of 3 plus 8, since the distance are 8, so 3 plus 2 plus 3 is 8. So for our RB is equals to 60.8 kN. So for our summation Fy is equals to 0, we have to get the reaction of all the point load. So point load of triangle, negative 1/2, since the line of action is directing downwards. So it is negative 1/2 times base times height is 5 times 3 minus the area of rectangle, since the line of action is downwards, it is negative, so 5 times 3 base times height plus our RB is the 60.8 kN minus 20, point load 20, pointing downwards, so it is negative, minus area of rectangle 5 times 3, also negative, minus point load 5, point load 3, and point load 10, all directing downwards, so it is all negative, minus plus the area of triangle, since it is positive because it is pointing upwards, times 6 times our base 3, 6 times 3 plus RA. So it is equals to, our RA is 5.7 kN.